Joining with us today is Devatrai Jha, a final year biotechnology student at the Netaji Subhash University of Technology. But calling her just a student would be a huge understatement. Devatrai is an emerging researcher whose work seamlessly combines with computational biology with experimental biotechnology. She is currently working on her bachelor's thesis on affinity maturation of antibodies against the monkeypox virus, where she is developing affinity mature antibodies using molecular docking, molecular dynamics simulations, and laboratory validation techniques. Her research journey has taken her across various prestigious institutions, including an international research internship at Shankyun University, Taiwan, along with a research experience at INMAS DRD, and several multidisciplinary scientific collaborations. Her achievements are equally inspiring as she has co-authored multiple book chapters, earned prestigious scholarships and academic distinctions, represented India through nationally recognized science projects, and co-founded the flagship NSUT Research Network, helping students research opportunities and build meaningful academic collaborations. From being an award-winning innovator during her school years and becoming a young researcher contributing to the cutting edge of biomedical science, Devatrai's journey is a perfect example of turning curiosity into discovery and imaginations into the reality. Devatrai, it's an absolute pleasure to have you with us today.
It's a pleasure being with you. That is a very flattering introduction. Thank you. I'm honored.
Actually, even I was so fascinated after reading your achievements and the kind of work you do. I've met so many seniors, but I guess you are the very first one who is continuing her, research in such core fields like no one else could think of, like in their bachelor's degree to pursue with.
Thank you so much.
Can you give a bit about yourself from your end as well?
My end. For as long as I can remember, I've always wanted to go into research. And I think part of the reason was how my parents always bombarded me with a lot of random facts and science trivia. So again, I really love biology and I aim to go into translational research. So molecular biology, cell biology, and developmental biology are the core areas that I want to focus on alongside immunological applications. And like you said, I've been into science fairs at school, and now I'm about to begin my master's at Julius Maximilians University of Wolfsburg in Germany. So I'm excited for that, and let's see where the research journey takes me.
Many, many congratulations for such an incredible news. Like, I guess it's our podcast is going to be the one जिसको पहले ही सबसे पहले पता चल रहा है कि one of our seniors is going to Germany for pursuing her research. Like, many, many congratulations once again.
Thank you.
So let's start off with the very first round. That is the beginning. So since every research starts off with the curiosity before a publication internships, there was simply someone who was like into liking asking questions. Like every researcher has a mind of asking questions. So very first question is, when did science stop being just another school subject and become someone that you genuinely wanted to pursue it?
I think I was a little ridiculously young. So I think around 7 or 8 years old, I already knew that science had to be the thing I want to go into. And like I said, it was really my parents who played an instrumental role, because I would be reading storybooks alongside encyclopedia, and I'd be watching Disney Pixar movies alongside documentaries. To be very honest, I flipped through the encyclopedias just for the pretty pictures, but I think somewhere it did fundamentally seed within me the idea that there's a lot of things that I want to understand about how we work, how we came to be, how we've gone from a puddle of primordial soup to single cells to this very complex organism that is, the human species. So I think that's when I realized I wanted to get into biology and into science in general. And then I think all of it just one thing led to the other, and I got into a lot of interesting science fairs. I asked a lot of questions. I know I pissed some of my teachers off because I'd always be interrupting lessons with questions. But I think teachers also play a very important role into shaping us and uh, putting us on the right track. So I think they also played a really strong role. And yeah, here we are now. So I think that was the beginning, like you said.
Really, I can even connect the same thing because, like, even my mother was a librarian. So whenever I used to go to library, I always took out that encyclopedia and just start flipping it because it's that's like too many variety of pictures that even makes small kids curious about like why it is happening and such stuff like that. And genuinely, I can really connect with the point that you already said that science fairs, the exposure to science fair is the one thing. Because when I saw this achievement of yours, like you went to CBSC state level science fair. So actually, I was also went to nationals via
Oh,
that particular fair.
yeah.
That is Rashtriya Bal Vigyanik Pradarshini. So I think, yeah, it's generally very overwhelming experience for anyone who just get into uh, science fairs and get to learn a lot of new things. So moving with Edith, many students who are entering engineering uh, just or after getting biotechnology, they starts underestimating themselves that as we even already know that biotechnology has a very limited research areas in India, and uh, it's very hard to even just see what all opportunities we can get in biotechnology. So if a person is who is just want to start off with the research journey in biotechnology, so how would you say ki, like one should start off with? Uh, I want to have a word in that as well.
Certainly, I think biotech is made up to be one of the lower branches. So that can diminish a person's morale. But a starting point would be to, I know this is going to sound cliche, but would be to really look into your textbooks. Not because they're everything, but because they really give you an avenue to figure out what potential areas interest you. So, if, for instance, biochemistry feels very boring to me, but I find immunology pretty interesting, I know that this is one of the areas I can look into. Alongside that, even in NSUT or most colleges, I'd say, uh, the professors do know their stuff. That's why they're there, right? So you can look into their work. A lot of them have really good publications and really interesting experimental work, even if they have not continued it into the recent years. So reaching out to them, asking them what exactly they do, and having maybe a small internship at their labs is the way to go, because biotech is a very application based field, right? You start by reading, of course, but you cannot rely just on the theoretical work. You need to actually hands on try things in the lab. So that is an exposure. Like the wet lab exposure is something you should really be getting on early, in your earlier stages. So I'd say try to get internships, be it at college or more preferably outside of your university campus. And the opportunities are less, no doubt, in India for biotechnology because we're a little behind when it comes to catching up to trends, right? If 20 years ago IT was a thing in US, it's a thing now in India, and the market is saturated. So again, that's the same with biotech. We're going to be late on the train, but I think our generation has the baton, and we have to be the torch bearer and figure things out. So I'd say yes, try getting internships and try working in a lab. That's very important. Be it in your own home state, or I think we're old enough, a lot of us are staying at hostels and PGs, right? So over the summer, I'd say a lot of people should be trying to get internships, even in labs outside their home state. And yeah, that's the best experience you can get. And international opportunities, they are not less, yeah, because US, France, Germany, Japan, even Taiwan, because I've been there, I know, they have labs that will really open your eyes to what research should actually look like. And so There's no dearth of opportunities. Apply as much as you can. Cold email people. If you reach out to 10 people or 100 people, maybe one or two might reply. So just try to get an internship and practical hands-on experience. That would be my advice.
Uh, like I totally agree with you. Like you have been giving us tips that how to start off with the research, and thanks. So I would also like to ask one more point. Like, do you actually feel the curriculum which is designed in the college currently in India, uh, as we have already seen at NSUT, how much it has added to your actual research domain which you are working upon, or in general as well, like whatever you are studying in biotechnology college curriculum, how much is actually helpful if we are considering carry forwarding our future in biotech?
Okay. I'd say a lot of times students make it out to be very deficient. We cry about how it does not match, the curriculum does not match the demands of any research field. That's not completely true. I think that the foundation this curriculum has given me is very instrumental. And for instance, I could not have worked on antibody engineering without first realizing what antibodies are and how they work, right? So I'd say the curriculum makes a very good framework for me. It is, however, severely lacking in a few of the more recent and upcoming domains. For instance, at NSUT, we do not have very robust computational biology courses, right? We have bioinformatics, we have structural biology, but they never really delve into AI. And I think AI is the buzzword. It really is the future because everything from drug discovery to antibody engineering to the future of diagnostics hinges very firmly on artificial intelligence and machine learning. So I think the newer subjects or subfields that are popping up in the world, that is something that should be better integrated into our curriculum. Because when we graduate versus when someone from, say, MIT graduates with the same 4-year BTech degree in biotech or bioengineering, we are lacking in very upcoming fields. And so that kind of computational work is something I've had to personally get into with the help of my guide alone, or with the help of a lot of YouTube tutorials, molecular talking or molecular dynamic simulations. These should be taught at a very fundamental level, especially because we have in engineering a lot of tech savvy people. So by focusing the entire curriculum on very fundamental core biology subjects, you repel these people from potentially taking interest in the field that they're actually learning. So I think integrating these things early on can really help more students realize the fact that they might actually be interested in biotechnology and the subfields it has to offer. So I'd say I have mixed feelings about how good the curriculum is.
Hmm. Weren't you were excited about the extracurriculars field as well, like being a academic enthusiast? Uh, wasn't there was a spark related to, like, what if I am not exploring that particular field? Does it don't it create a FOMO in you as well? No, if I'm not doing it, I will be out of the whatever people are doing. So yeah.
So for context, I joined 7 to 8 societies in my first year.
Okay.
And as my degree progressed, I kept dropping a lot because I wanted to focus more on research. So I was in depths of the debating society. I continued to be in the Alliance, the journalism, the newspaper society. I was in the quiz club because I really love quizzing. And again, that's something I continued. And I applied to Crescendo, but I was not good enough for them. But yeah, singing in the shower is something I do. So I think personally, a lot of scientific minds do have a creative flair. It's a misconception that, someone who's interested in academics or research is going to be very hardcore in it. And at the end of the day, we're all humans and all of us have our different creative outlets. Like one of my professors, he's really into poetry, right? So he's retired and he has amazing work, a lot of patents, but he likes poetry. And so I'd say, again, that's a misconception. So we do have creative things, and it's something I did more in my personal time instead of participating in more competitions. I did participate in a lot of debates, even after leaving DepSoc. But yeah, these are hobbies that I pursued on the side, or I would have gone mad. Just lab work would have driven me insane. So don't worry, I did not leave that.
Okay, okay, for sure. Because like some people have this misconception, like if somebody is there into deep research or much more into academics, would have sacrificed a lot on their extracurricular side. So it's a misconception only. Like people haven't seen that particular area. Yeah, if a person is doing something else, so he also might have explored that extracurricular side, but he is not that much. Showing it off to everyone that I also have that particular side to, explore it. Genuinely. So now let's move on to the second round, that is the turning point. Among all your research experiences, which opportunity has transformed your perspective the most?
I think my research internship at Chandong University, Taiwan. So I was working with Dr. Line Pei, and she's essentially working on Drosophila melanogaster, which is the fruit fly. And her lab has a lot of intersecting and intriguing projects. So my work in particular was on analyzing the filament levels of the enzyme CTP synthase and correlating that with senescence, aging, as well as colorectal cancer progression. And so I was dissecting flies, taking out their intestines. Sounds gruesome, but again, I'm sorry. I know I'm going to sound like a monster, but I enjoyed the dissection. So yeah, I was dissecting them, immunostaining them, making slides, and then performing confocal and fluorescence microscopy. And I think the labs there were so beautiful. I think they made me fall in love with research all over again. And that was a very different kind of work because previously I had observed at INMA's DRDO, I had observed mouse mesenchymal stem cell extraction. So stem cell is a very different domain. And then Drosophila was a very different domain. And then my thesis, antibody engineering, is a very different domain. But I think that was something that I can see myself working on even in the future. So that's definitely a turning point in my life.
Following up on your internship at Taiwan, like I would like you to just elaborate on the point that how did you landed up the internship at Taiwan and how the process went, and was it a scholarship based or was the expenses everything was included from your end?
Okay, so the Ministry of Education of the government of Taiwan has two very interesting programs for upcoming researchers, be it undergraduates, postgraduates, or even PhD students. One is IITP, and the other is TEEP, Taiwan Experience Education Program. And the latter is the one that I went through. So the whole process involved firstly scouring through their website to see which professors' work I liked. And honestly, there were like at least 50 people. I cold emailed them, briefly introducing myself, sharing my research experience, my CV, my transcripts, all of that. And the professor reached out to me, she replied, and scheduled an interview. So that was a not face-to-face, online interaction where we discussed the work that I've done and the work that I aim to do at the lab. And she liked me, I guess. So, she had the whole, all the official documents prepared from her university, and then visa, flight, everything. And next thing you know, I was in Taiwan. So that was the procedure. And in fact, I'd recommend you as well, maybe next year and your friend, to apply to international internships because they really give you a very different perspective. And I say this with a little bit of sadness, but their labs are generally better than Indian labs, at least for biotech. I don't know about other areas of research. And you asked about the scholarship. So it was completely paid in the sense that they paid me a stipend according to how many months I worked there. The flight tickets and the living expenses, of course, were managed by myself. But whatever they paid me went into my stay there. So I'd say it's, balanced out.
So yeah, like there are a lot of opportunities one should explore, and yeah, we should be enthusiastic enough to just reach out and just scroll for those opportunities and perfectly choose one to land upon.
Yes, absolutely.
Uh, was there any opportunity you almost didn't apply for because you felt you were not good enough?
Uh, yes, I think there was. Uh, During my second year summer break, actually, there's this very interesting program that you have. It's called the Summer Research Fellowship Program, SRFP, by IAS, INSA, NASI. These are three different research institutes. And this is in partnership with the Indian Institute of Science. So I felt like I was not good enough to apply to that. But with a little push from my family and my friends, they were like, you know what, you have nothing to lose. Right? The worst they can say is no. So I thought, okay, let me give it a try. And I ended up getting that internship. It was in a different field, though. It was mostly environmental sciences. So there I worked on pyrolysis of different agricultural wastes to get activated biochar. And I built a small air purifier out of it. So yeah, I think that was something I did not think I'd get, but yeah, the rest is history.
Also, like you highlighted a lot of new pointers related to foreign university and their lab. If there was one point where I would ask you to compare between the Indian institutes like IITs and IISCs for research and foreign universities, like one of which you are going to pursue research. What is the main difference you think is there in terms of when a person wants to get into research field? So, why would people prefer foreign universities rather than Indian ones? And if somebody goes to prefer Indian ones, uh, how they can just ace it very like in whatever path they choose?
Okay, so I haven't been personally to any labs at IITs or IISc, but I have been working at JNU. So that's something I can comment on. And I'd say funding plays a very right? Because most of the European and American institutes are very heavily funded. And these things show up in the smallest of things, like they have 10 different types of pipettes, right? And whereas personally at NSUT, for instance, um, some of the equipment does not work or is not accessible to undergraduate students. And I think undergraduate studies are one of the last phases in a student's life where we can actually get them to, grab their attention to come into a certain field. And if you don't provide that kind of infrastructure and that kind of facility, you will have them lose interest. So I'd say funding and by extension, the equipment and the facilities they have really makes a lot of difference. Even in Taiwan, that's something I noticed that they didn't really have to worry about buying something that they needed for their research because they had enough bank balance, they had enough grants. And India really struggles with that. Even my lab at JNU, it was really, really nice. They had everything they wanted, but every time there was a deficit, they had to wait for a grant. Like they're having to wait for a grant right now to get some expensive antibodies, for instance. So I think that hindrance forces Indian researchers to cross a lot more hurdles compared to the ones based in US or Europe. Because if you're having to figure out and wade through a lot of things, a lot of basic things, you're having to struggle for a lot of these, basic facilities, then somewhere it discourages you. So I think that's a downside of Indian universities. We're not very well funded. But I would say that if someone does choose to go into Indian universities, we do have amazing research at a lot of places, like DRDO, for instance, right? They're one of the few very well funded institutes in India because they deal with defense research. And their labs were good, no doubt. Like they had live mice and guinea pigs for research. They had whatever they could possibly need. So I'd say look for good labs, look for good universities. The better known your university is, we assume the better their research is, but that's not always true. Sometimes you'll find smaller institutes conducting good research. So according to your interest, but do keep facilities in mind because they can really either make or break what of your interest.
Yeah, I guess after listening to you, I had come out to a very good conclusion about the university comparison, because even I tried looking for this comparison, but internet sometimes not properly highlights upon this particular point. So there I felt ki, yeah, if a person who has actually faced this whole research process would be the best one to tell about how to move forward with the things. Moving to next round, that is inside the world of research. So the question is, people usually see publications and internships, but they don't see the field experiments. Can you tell us about an experiment or a project that didn't go as planned and what it taught you?
Oh, so actually, my current research is failing, and we don't know why. But essentially, what we're trying to do is we designed SCFPs, which are a class of antibodies, and we're trying to get it to bind to a specific surface protein on the monkeypox virus, which is an emerging public health emergency. So we expected that after the whole, you know, protein production in bacterial systems, and then protein purification, and then the nickel NTA pull down assay, we'd be able to see them bind. But that has not happened. And right now, I'm just trying to figure out how to troubleshoot the problems. I think a big problem with publications as well is the fact that they do not accept failures in research. And if I, as a researcher, am facing a setback, and I want to know if any other researchers in the community have faced it, I will not find it in a research paper because they don't allow you to publish these failures or these setbacks. Instead, I am forced to turn to a lot of forums, including the ResearchGate Q&A platform, as well as, unironically, Reddit science communities. They're ridiculously helpful. So there's a lot of scientists there discussing, oh, well, this experiment didn't work. Can anyone highlight what could be the issue? Or, oh, my stem cells are contaminated. Does anyone know what this could be? And I think that presents a very interesting dynamics in the world of research, because where we turn to answer questions about troubleshooting issues goes to show that the formal channels have not accommodated the failures that researchers face on a day-to-day basis. So the issues I'm facing, I don't know how to solve it, but I'm trying to figure it out. Let's.
क्या कहते हैं, कोशिश करने वालों की कभी हार नहीं होती. Statement really comes into play. Like every time we are feeling, we are continuing with, like I guess in every domain the same thing happens. Like we try several times, we fail several times, but the point is, the longer time we last on that particular thing, surely at one point we are gonna get success.
Absolutely. Research is like research is like a marathon. So you have to keep going. Yes.
Yeah, definitely. So my next question is, what does a normal day inside a biotechnology researcher lab look like?
I'd say we repeat a lot of things, certainly, because if things fail once, like for me personally, the work I'm doing right now, we had issues 2-3 times. So we had to culture cells all over again, extract proteins all over again. So some processes become a little mundane after a point. But yeah, an average day is like, you wake up, you get to the lab, and you pray that you get good reproducible results. And I think it's not very hard to figure out work-life balance. Unless you're a PhD student, then your life is sad. But yeah, it's mostly experiments and very short breaks and some sleepless nights. But yeah, otherwise it's like you spend most of the day in the lab. There's not much going on in your life, to be very honest.
So, you are, moving to Germany for your master's or for PhD?
That's actually a master's PhD fast track course, which means that I can complete my MSc in 1 year instead of 2, and then immediately jump into PhD. So, yeah.
In total, I guess it will take 5 or 6 years.
Yes, hopefully not more than that.
Okay, then. Now let's move to the next round. That is the rapid fire round, the hot seat round, we will say.
All right.
So, the very first question, one scientific myth you wish students stopped believing.
You get good results the first time you try it. It does not happen. At least 4 to 5 days.
Okay. Next question, wet lab or computational biology?
Wet lab any day.
How would you explain what difference between a wet lab and how does a computational biology looks like?
Wet lab is very hands-on. So that's the traditional labs you go to and you have to physically perform experiments. So that would include methods like transformation, DNA or RNA extraction, protein extraction, Western blot, SDS page, agarose gel electrophoresis, all those techniques. So that's, again, the stuff you usually see scientists do, in your traditional settings. Computational biology is what you'll see, people latching onto computers and these really complex, heavy computer systems. So a lot of times it involves a lot of AI, ML, a lot of coding, usually Python and stuff. And but today they're very integrative. No research paper can stand on the shoulders of one field alone. So you have to use it.
I guess multidisciplinary things are coming into play a lot. So in every domain, there is like involvement of two, three more domains to get to a very, extraordinary output, we can say.
Absolutely.
One laboratory technique you secretly enjoy doing?
Dissection.
Next question is coffee, tea, or pure determination?
Pure determination.
Research paper or Netflix?
Research paper.
One word that describes your journey?
Peculiar.
Okay. So, how do you deal with self-doubt, especially when the research doesn't go according to the plan?
First, I cry. I cry a lot. And then I force my mother or my best friend or my brother in my family, one of these 4 people, I force them at gunpoint, pep me up and say good things about me so I get my confidence back. And then I think I eat some chocolate and I get back to it.
Okay. That's a very cool way. Like, I can't say this ki, Mummy, Papa, meri taarif kar do, please. Thoda sa mere ko get back.
Thank you, Badi Beti is a very scary and real character, and I'm that, so I can do it.
Okay.
Yes.
Moving to the next question. You co-founded the NSUT Research Network. So, what was the main aim behind it, and why did you felt like giving back to the student community was an important aspect of your life which you felt after completing your undergraduation, or like you have just in need of final year? So what was that particular thought behind it?
So this was actually the brainchild of my junior, Extracurricular. I think he's your batchmate or your senior.
He is our senior. I guess he's here 1 year soon. We are just completed our first year. We are just entering second.
Yes, he's definitely your senior. Yes, so it was actually his idea. And he reached out to me and he said, okay, I have recognized the fact that being interested in research myself, we don't have a lot of mentorship, especially at our university. We don't have enough seniors telling us what to do and how to do it. And I was like, yeah, same, because I think I've been very lucky in that sense to have a few really good seniors at Alliance or at the Quiz Club who've told me, okay, this is a research internship you can apply to, or these are good master's programs you can look into. But I realized the fact that not everyone has those seniors. I've just been very lucky. And I think I want to be that for my juniors as well. And it's really important to give back to the community because I can't do any good to my seniors. Right? They already know the stuff, they know more than me. So my way of coming back full circle is to give what I have received to the ones who are going to follow the same path of research. And I think, yeah, that was the motivation behind it, because we really need a collective space, a collaborative space for a lot of students to come together, ask their questions, and get good guidance from people who have been in their shoes and who have potentially struggled more because we didn't have people telling us the things that we are telling you now. And I think that's important at any institution. So that's what we're trying to impart.
Definitely, like I was very, very surprised to see, like even I feel myself lucky because when I entered the college, there was no research network who was like doing this. Then one day you came into our class and you told us we are starting off with this new society such that we can work about it. And even I started telling it to my friends as well who are into different colleges, and even they were shocked to like seriously. ये सब भी हो रहा है मैंने बोला यार yes that's the reality and even like we started when we started discussing and when the content started to come on that NRN group I was genuinely very very happy to see all the opportunities that are coming and I can't just wait to be the part of that NRN. Yeah,
I'm glad.
So now let's move to the round 5. That is advice for some students. If someone wants to build a strong research profile in biotechnology over 4 years, what roadmap would you suggest? Like in just 4 pointers, to the point, we'll keep this question because I guess you have highlighted this thing earlier as well.
Yes. So first will be, especially in your first year, not a lot of institutions outside your college will be willing to take you in for an internship. So that's the point where you should reach out to your own professors. So go and work in their labs, figure out what you like, read research papers, check out podcasts, and see what interests you the most. And in fact, do turn to textbooks as well. So that's step number 1. Get internships or some experience in your own college and figure out what you like. Second year and third year, apply everywhere you can. Okay, as many internships as you potentially can in your state, outside your state, all over India, internationally. You will get a lot of experience. And that way, if at the beginning you think you like 5 fields, you might be able to narrow it down to 1 or 2. That's step number 2, as many internships as you can. Number 3, on the side, do projects that might interest you, right? And try to publish papers. Definitely, be it review papers, be it book chapters, be it research papers of your own, because definitely by your 4th year for your thesis, you will need a paper for your thesis to get the best of the grades. So publish if you can, and I'd recommend have at least 1 paper by the time your bachelor's is done before going to your master's. 4, beginning of your 4th year, if you have already figured out that you want to go into master's or PhD or academia in general, make your profile very robust and prepare everything you need, right? Especially if you want to go abroad. You will need to clear a lot of exams, so you'll have to study for them. Be it GATE, be it GRE, IELTS, all of those things. So prepare well before time, apply well before time, and bonus point will be don't lose hope. Reach out to people and pursue your hobbies. Do not go mad. That's it.
Suppose a first year student says, I don't have connections, I don't know any professors, I don't even know where to begin. What would be your advice to them?
Go to your department, bother all the professors. See or go to the website, see the professors who are working in different domains in your department, and then manhunt them. Literally go bother them, tell them that you've gone through their work, and please do go through their work before reaching out. There's a lot of papers on ResearchGate or stuff you can find about them. So whoever seems friendly and accommodating to a first year student, reach out to them, bother them, and work in their labs. It is not hard. All of them are genuinely trying to help.
Now, whosoever is gonna watch this podcast, you have a bestest of the roadmap you can look after to get into research domain if you really want to get into very good research areas. So moving to the very last segment, that is Kalpana versus Vastavik. So what this whole round looks like I will be telling you a statement. You have to tell whether it's a Kalpana, like it's only exists in imagination, or is it the reality, like true or false. First, only students with 9.5 plus CGPA can get into research.
False.
Research is only for geniuses.
Again, false. Kalpana.
International internships are impossible unless you already have strong connections.
Kalpana.
If an experiment fails, you have wasted your time.
Kalpana.
A biotechnology career is limited to laboratories.
Kalpana.
Finally, when you entered the college, what was your one belief you had about research or success that was completely changed after experiencing the reality?
I thought research, the road to research would be a very linear path and something I could plan out, with little sticky notes and everything, that I'll do this first, then I'll win this, I will get this internship. I had it very straight. And I think the actual world of research has really shattered that illusion. It's a very meandering path, full of a lot of roadblocks, a lot of challenges, but these challenges teach you a lot more than successes could. I know I sound like a grandmother right now, but that is the reality. So it's very branching, and one failure can really open up a lot of other doors. So that's something that I have learned in these last few years, and something I want all students to realize.
Like, definitely one should look after all this and can get a very good comprehensive idea at how things get clear with time. And yeah, we shouldn't lose hope very early, like whenever we are just starting. So very, very last question to just wrap up with the podcast. If your entire journey from your first day in college to today had been captured in just one sentence, what would that sentence be?
My journey reads like a coming of age fantasy Ghibli movie, and I'm proud of that.
Thank you so much, Devatrai Ji, for this wonderful, insightful words which you gave us. And whenever this podcast goes live, this is genuinely going to help a lot of people out there, because, like, even I see in my classroom people who are just studying biotechnology, who like just left at class 10, leave biology at class 10. And when we enter the college, this biotechnology from a very lower branch, people start thinking that there is no future. After 4 years, what will gonna happen? So we have some of the great inspiring series like you who are definitely gonna be our role models to follow the path. So thank you so much for your time. It was pleasure having you on our podcast. So with this, we comes to an end of this episode 3 of Kalpana Se Vastavikta Tak. Thank you. Bye bye. Take care. Shabakher.